Hello friends, I welcome you in lecture number 7 on relations. In this lecture, we are going to discuss two more properties of relations. First one is irreflexive relation. A relation R on this set A is called irreflexive if for every A in capital A, order pair AA is not present in R. If for every element of a given set A, order pair A, A does not belong to R, then relation R is called irreflexive. So if your relation contains this type of ordered pairs, then it cannot be reflexive. It cannot be irreflexive. In other words, relation R is irreflexive if no element in set A is related to itself. This we can rewrite in this way also. A is not related to itself by the relation R. So relation R is irreflexive if no element in a given set is related to itself by that relation R. We consider this example. Suppose set A has three elements A, B, C, and let R be the relation containing order pair A, A. Then we can see that for element A in this set, order pair AA is present in our relation. Therefore, R is not irreflexive because order pair A, A belongs to R for A belongs to A. Or we can write that because A is related to itself and A is present in a given set. We have taken another relation on the same set denoted by capital S. It has these three ordered pairs and we can see that all these pairs A, B, B and C, C. We have three elements in the given set and we can see A is not related to A because AA is not present in S. Similarly, B, B is also not present in S and C, C is also not present in S. In other words, no element of set A is related to itself by the relation S. Therefore, this relation S is irreflexive. So, in short, our relation is irreflexive if no element is related to itself for all the elements in a given set A. Another property is asymmetric relation. So definition is obvious from the word asymmetry. A relation R on the set A is called asymmetric if AB belongs to R implies that BA is not in R. If we recall the definition of symmetric relation, then relation is called symmetric if AB belongs to R implies BA belongs to R. And here we are writing definition of asymmetric relation. So here if we change the order of elements, then this is not present in R for asymmetric relation. So that we understand with this example. Suppose set A has four elements A, B, C, D and R is having all these ordered pairs. R is a relation on set A. Then R is not asymmetric because this is present in R. If we use the definition, then definition says that if some element is present in our relation and if we change the order of components in the order pair, then resulting element must not be present in the relation. So here if I change the order of these two components, then I obtain the same component and that is present in relation R. Therefore, R is not asymmetric. So if you want to prove that your relation is not asymmetric, you have to find out at least one element such that this condition is not satisfied. For other elements, we can see if I change the order here, then I obtain the element B, A that is not present in R. Here also, if we change the order of components, resulting order pair is B, B that is not present in R, and same thing here. Here if we change the order, we will obtain A comma D, that is also not present in R. But this order pair is creating the problem, and therefore R is not asymmetric. BB belongs to R implies BB belongs to R after changing the order. So our relation is not asymmetric if at least one element in the relation is related to itself. Here B is related to itself by the relation R, therefore R is not asymmetric. So if we want to make this relation asymmetric, we have to remove this order pair BB. If we remove this order pair, then R will become asymmetric. This is another relation on the same set, S equal to order pair AB, CA and AD. Here we can see if I change the order of components, then I will obtain B comma A, that is not present in S. Same thing here, if I change the order of components, I will obtain A comma C, that is also not present in S. And for this order pair, after changing the order of components, we obtain D comma A, that is not present in S. Therefore S is asymmetric relation. So these are the two simple another properties of relations. We just recall again that relation R on a set A is irreflexive if A comma A is not present in R for every element in a given set, and relation R is asymmetric if AB belongs to R implies BA is not in R. In other words, if A is related to B, then B is not related to A, and here A and B are elements of given set. So these are the two more properties of relations, and we have discussed them with the help of examples. And in the upcoming lectures, we will be discussing some more problems on properties of relations. Thanks.